Hey. All right. Hey, ladies and gentlemen, this is Miss Humber here. So we're going to do Unit 2, Notes 3, which is Solving Systems by Substitution. So we're going to take a look at algebraically solving systems. Previously, we were just doing it by graphing, which isn't always the most accurate. So today, we're going to look at doing it algebraically. So let's go ahead and get started. So first of all, we need to take a look at the steps that we need to follow in order to solve systems by substitution. So step 1 is to solve the systems for one of the variables. So if it's not solved for x or it's not solved for y, we need to solve one of our equations for x or y. Then we're going to substitute that expression into the other equation. Okay, once you do that, if you've done it correctly, you're down to one variable, which is good because then you can solve for the remaining variable. Once you're down to one variable, you can solve. Then you can take that variable, plug it back into one of the initial problems, and get your variable. So this stuff does get a little confusing, so I encourage you to watch the video multiple times if you need to, as well as there are extra resources in the folder on Schoology that you can look to as well for more examples. So let's go ahead and let's take a look at this. So let's do what type of solutions we can get. So sometimes when you're using substitution, you can get rid of both variables. The variables x and y cancel out, and you're left over with a true statement, meaning 6 is equal to 6, 3 is equal to 3, 2 is equal to 2, something like that. If what's left over is a true statement, then you have infinitely many solutions. Now, if the variables cancel, what's left is false. For example, 6 is equal to -2, 2 is equal to 4, anything like that. Where it's false, then the system is said to have no solutions. So let's go ahead and let's take a look at some of these examples. So again, it does get a little confusing, so I encourage you to watch the video a couple of times if you need to. You can do this. So here we know that x is equal to 2y plus 36. So what that means is x and 2y plus 36 are the exact same thing. You can use them interchangeably. Sometimes I'm not in school, so another substitute teacher comes in and completely takes my place. So that's what we're going to do. We're going to take this x right here and we're going to take it out. I'm getting rid of that x completely and I have 2y plus 36. So I'm taking that x out and then I'm going to write the rest of the equation exactly as is. So all I did was take x out and I replace it from what I have in the second equation. So now I can solve this for y. So I'm going to combine like terms. 2y plus 2y is 4y plus 36 is equal to 8. So now I want to get that 36 over to the other side. So I'm going to subtract 36 from both sides. So then that cancels out and I'm left with 4y is equal to 8 minus 36, which is going to be a negative 28. So now to solve for y, I need to divide both sides by 4. When I divide both sides by 4, I get that y is equal to a negative 7. So y is equal to a negative 7. So now I know that is the case for one of these. So I'm going to go up to the top, and where I see y in this equation, I'm going to plug in negative 7. Now here's the beauty about this whole thing. It doesn't matter which equation you plug it into. I chose to plug it into the second one because it's already solved for y. So what I'm going to do is I'm going to rewrite out that second equation exactly as is. However, instead of writing y, I'm going to write negative 7 instead because I know that y is equal to negative 7. So then I get that x is equal to a negative 14 plus 36. Well, negative 14 plus 36, well, that's going to give me 22. So I get that x is 22. The last thing you need to do is write your answer out as a coordinate point. First your x, and then your y. So 22, negative 7. That's your final answer for number 1. Let's take a look at number 2. So for number 2, before we can solve it, we need to have one of those solved for a variable. So what I always do is I look for a letter that only has a coefficient of 1. So I see that this x has only a coefficient of 1. So that makes it really easy to solve for. So I'm going to take this equation and I'm going to solve it for x. So the first thing I'm going to do is bring this 2y over to the other side. So then I get that x is equal to a negative 2y plus 15. So x and negative 2y plus 15 are the same thing. So I'm going to go ahead and where I see x up here, I'm going to take this guy and I'm going to plug it in for that x. So I'm just removing that x. Everything else is going to stay the same. So I'm going to end up multiplying that 2 that was on the outside of the x by everything. And then the rest of the equation is going to stay the same. So I'm going to have minus 3y is equal to 2. All of that stays the same. So now I'm going to take this 2 and distribute it in. So 2 times negative 2 is a negative 4y. 2 times 15 is 30. Minus 3y is equal to 2. So now I need to combine my like terms. So negative 4y minus 3y is negative 7y plus 30 is equal to 2. So now I want to get my plus 30 over to the other side. So I'm going to subtract 30 from both sides. So I get negative 7y is equal to a negative 28. So now I'm ready to solve this for y. So I'm going to go ahead and divide both sides by a negative 7. Well, that's going to give me that y is equal to a positive 4. So now I know that y is equal to a positive 4. So I'm going to think back to what I did at the beginning. When I solved this equation initially, I got x is equal to a negative 2y plus 15. Remember, that's where I got at the beginning, way up here. When I solved this equation, it ended up with this. Well, this is already solved for x, so that seems convenient for me to plug in my y is equal to 4. So I'm going to rewrite this equation out, and instead of writing y, I'm going to substitute in that 4 instead. So I get x is equal to negative 2 times 4 plus 15. So that's a negative 8 plus 15. So then I get that x is equal to a negative 8 plus 15, which is 7. So my x is equal to 7. So last but not least, we want to write this out as a coordinate point. First my x, then my y. So my solution to this system is 7, 4. Let's take a look at number 3. Now number 3 is almost solved for x. To me, it looks really easy to solve this equation for x. You could choose to solve for y if you wanted to. You just might get a decimal. So I'm going to solve this equation for x so that I can use substitution. So since this is a minus 3y, I am going to add 3y to both sides. So then I get that x is equal to 3y. So x and 3y are the same thing. So in order for me to get my equation solved, I'm going to have to plug that in for x into the other equation. So the equation I didn't use, I'm going to plug in for x right there. So I'm going to take that x out and I'm going to put 3y in instead. So then I end up with 7y is equal to 26 plus 11 times 3y. Again, the rest of the equation stays the same. I'm just taking out that x portion. So I remove x completely and I put 3y in instead. So I have 7y is equal to 26 plus 11 times 3 is 33y. So now I need to get my y's onto the same side. So what I'm going to do is I'm going to subtract 33y from both sides. So 7 minus 33y is going to give us a negative 26. Okay, so we have negative 26y is equal to 26. Well, that 26 is being multiplied by the y. So I'm going to take that and I'm going to divide both sides by a negative 26. So 26 divided by a negative 26 is a negative 1. So y is equal to a negative 1. Y and negative 1 are the same thing. So I'm going to scroll back up here and I'm going to take a look at the equation that I already solved for x. It doesn't matter which one you plug it into. You can plug it into this one, you could plug it into this one, you could plug it into this one. It doesn't matter. So what I'm going to do is, because this one is already solved for x, I'm going to plug my y into that one. So now I know that my y is equal to negative 1. So I'm going to rewrite out that equation. And where I see that y is negative 1, or where y is, I'm going to put in that negative 1. So 3 times a negative 1 is a negative 3. So now I have my equation. X is equal to negative 3 and y is equal to 1. So we have negative 3, negative 1 as our final answer. Okay, again, you want to write it as a coordinate point. First your x and then your y. So taking a look at number 4. So for number 4, what we have is we have two equations that are solved for y. So that's great. That makes it really easy to use substitution. Well, here I get that y is equal to 4 plus x. So 4 plus x and y are the same thing. So where I see y up here, I'm going to go ahead and I'm going to plug in 4 plus x. So 4 plus x is equal to 3x minus 4. So I'm going to go ahead and I am going to solve that out for x. So first thing I'm going to do is get this positive x over to the other side. So I do that by subtracting x from both sides. So I get 4 is equal to 3x minus x, which is going to give me 2x minus 4. Now I want to get that minus 4 over to the other side. So I'm going to add 4 to both sides. 4 plus 4 is 8, and that's equal to 2x. So 8 is equal to 2x. So now to get that x over to the other side, I'm going to divide both sides by 2, and I get that x is equal to 4. So now I know that x is equal to 4. X and 4 are the same thing. So where I see x up here, I can plug in 4 into that one or into that one. I'm going to use the second one because I think that addition is easier. So I have y is equal to 4 plus x. So I'm going to keep the entire equation the same, except where I see x, I'm going to put in a 4. So y is equal to 4 plus 4, which is 8. So now I get that x is equal to 4 and y is equal to 8. So then I have the equation 4, 8. Okay? Next, let's take a look at those couple equations on the back side. So, first of all, in order for us to use substitution, we're going to have to solve. This one looks like I could very easily solve it for x. So I'm going to do that. So I have 2x is equal to 4y plus 4. So I'm going to go ahead and I'm going to divide both sides by 2 so that I can solve for x. So then I end up getting x is equal to 4y divided by 2 is 2y, and 4 divided by 2 is 2. So I get that x is equal to 2y plus 2. So I have this, so where I see x up here, I'm going to take x out completely, and I'm going to plug in 2y plus 2 instead. So then, based off of that equation, I'm going to have 3 times 2y plus 2 minus 6y is equal to 6. So again, the entire equation stayed the same. All I did was substitute out the x. Everything else in the equation stayed the same. So now I'm going to simplify. I'm going to distribute in my 3. So then I get 6y plus 6 minus 6y is equal to 6. Well, here, okay, my 6y's are going to cancel out. And then I end up with 6 is equal to 6. Well, that's a true statement. Both of my variables canceled out. Okay, and since it's a true statement, that means I have infinitely many solutions, or IMS. Next, let's take a look at this one. We're going to solve this equation for y. That seems easiest to me. So I have 2x is equal to 7 plus y. So to get that over to the other side, I'm going to subtract 7. So I end up with y is equal to 2x minus 7. So I'm going to plug that in for y up here. Okay, so let's go ahead and do that and see what we'll get when we plug in. So now I'm substituting out y and I'm plugging that guy in instead. So I have 6x minus 3. Now I'm going to plug in 2x minus 7, and that's equal to 24. I kind of ran out of room there. So now I'm going to take that negative 3 and I'm going to distribute it in. So 6x times negative 3 times 2 is negative 6x times negative 3 minus 7 is a positive 21, and that's equal to 24. Well, here again, I have 6x minus 6x, so those are going to cancel out. So then I'm going to end up with 21 is equal to 24. Well, 21 is never going to equal 24, so for this guy right here, there is no solution. So that concludes your note video for today. I'm going to have you guys do a video on the second word problems tomorrow. So please make sure you remember to bring headphones to class, okay? And also take your Schoology quiz. Thanks for listening.